It's the beginning of another busy working day in Thailand and the end of a 7,000-mile journey for the cargo in this convoy. A consignment of around 70 metric tons of raw cotton from West Africa. It's a huge delivery, but it could be much bigger. Thailand consumes 1.4 million bales of cotton every year, but produces less than 2% of what it needs. So every year, Thailand imports 1.3 million bales of cotton, the equivalent of 300,000 tons. African countries produce 5.7 million bales and export 3.8 million, more than enough cotton to meet Thailand's demand. African cotton is generally good quality and often cheaper than other major exporters. But African cotton now amounts to only 10% of Thailand's cotton imports. Increasing those cotton sales can be helped by a better understanding of how a typical spinning factory works, the different processes involved, and most importantly, the quality of raw cotton the buyer needs and why. This Thai spinning factory uses three main automated spinning techniques: ring spinning, open end, also known as rotor, and air vortex spinning. Ring spinning is the oldest and most widely used mechanized method of spinning. In ring spinning, yarn is produced by continuously twisting and thinning the strands to make a very fine rope of cotton fiber. Twisting makes the short hairs of cotton stand out, resulting in a strong yarn which has high hairiness and is very soft to the touch. Ring-spun yarns are very high quality, but the process is expensive because of its slower production speed of around 20 meters a minute. They're also prone to high hairiness and need extra processing. In open-end or rotor spinning, cotton is spun using rotors, not spindles. Open-end spinning has a higher productivity than ring-spun cotton, at around 150 meters per minute, and produces coarse yarns, mostly suitable for bottom weights. The advantages of rotor spinning are lower labor costs, less power consumption, higher productivity, and less processing than ring-spun cotton. The disadvantages are that a wide range of count can't be spun, finer count can't be spun, and the resulting yarn is more bulky, with lower strength than ring-spun yarn. Vortex or airjet is the most recently developed method of spinning and inserts twist by a rotating vortex of compressed air. Vortex spinning has a very high production capability at around 400 meters per minute, 20 times faster than ring spinning. Fully automated, vortex spinning needs less labor and processing. It also has low hairiness and hence low pilling in the fabric, and it uses 30% less power per kilo of yarn than ring spinning. The downside is that vortex spinning produces a stiffer yarn than ring or rotor spinning and has a very limited range of yarn counts. The machinery is amongst the most advanced, sensitive and expensive in the world. Damage can be very costly. So before raw cotton can go anywhere near this equipment, it must be thoroughly checked and processed, and the results clearly marked on a report card like this. The report card covers everything from the exact net weight of the delivery, the condition of the bales on arrival, through to detailed analysis of the quality of the raw fibers. More importantly, it notes the level of cotton contamination. Contamination is a serious problem with raw or ginned cotton. A lot of cotton contamination is unavoidable, like dust, honeydew or broken seeds. But a great deal of contamination is entirely avoidable, such as metal fragments, dirt, cloth pieces, human hair, food wrappers, wire and plastic. As soon as a cotton consignment arrives, checking begins. Every truck is weighed before and after unloading, so that the net weight of the consignment can be logged on the report card. Each one of these trucks weighs around 43,000 kilos. The net weight of the cotton normally amounts to about 18,000 kilos, but the actual usable cotton will depend largely on the level of contamination. After weighing, the cotton bales are unloaded and as soon as they're opened, checked by hand for major contamination. A large amount of cotton contamination is simply due to poor storage and bad bale packaging. Many cotton bales arrive, torn open and damaged, exposing the raw cotton to moisture and dirt and other contaminants. The cotton that's just arrived from West Africa is actually very good quality, but poor storage and packaging has led to a high level of contamination. Good baling means the contents are protected, whether they're natural or synthetic like these. And using the right quality of polyethylene instead of metal straps for baling can reduce the risk of staff being injured. Once the cotton bales have been checked by hand for major contamination, fibre samples are collected for further testing. Every sample undergoes detailed analysis of fibre parameters, including length, strength, micronair, NEPs, short fibre percentage, trash and yellow spots immaturity. In the testing laboratory, half-gram fibre samples are rolled into 30cm strips and checked for short fibre lengths of under 12 millimetres and NEPs. Fewer than 150 NEPs per gram is satisfactory. More than 400 is unacceptable. The cotton fibres are then weighed into 100-gram samples and fed through a trash separator. This removes small fragments of leaves and other contaminants and collects it all as trash at the bottom. Fibre samples are also checked for moisture content. A normal reading is around 4.4. Above 6 is unacceptable. While random samples are tested in the laboratory, the bulk of the cotton bales are brought into the blow room, where what's known as the back-end process begins. In simple terms, the cotton is thoroughly cleaned and processed into small, clean fibre tufts. The cotton bales are laid beneath a plucking machine, which takes a small layer of fibre from the top of the bales each time it travels back and forth. The cotton fibres are then sucked up through overhead pipes and fed through a number of processors and sensors for more cleaning. Metal fragments are removed, avoiding damage to fibres or electrical sparks caused by metal friction. The cotton is now ready for carding, meaning fibres separation. Carding disentangles, cleans and intermixes the cotton fibres to produce a smooth, continuous strand, or what's called sliver, a rope-like strand of cotton fibres. If contamination or defects aren't removed during carding, they will stay throughout the spinning process and result in defective yarn. Then, in a process known as breaker drawing, 6 or 8 carding slivers are placed in parallel and drafted into what's called a single drawing sliver. At this stage, the yarn is ready for spinning, but only on 2 spinning methods, open end and vortex. The single drawing sliver is still too unwieldy and bulky to be used directly on ring frames for ring spinning. So in a process called simplex, the sliver is thinned and wound onto bobbins, which can then be fixed onto the ring frames for final ring spinning. Even after the cotton has been spun, the yarn still isn't ready for dispatch. It's conditioned and goes through rigorous quality controls. All the yarn winding positions are connected with a Euster expert to monitor the finished yarn quality. An ultraviolet light sensor checks shade variation, neps, density, and any imperfections. Finally, after this long and detailed process, the yarn is ready for dispatch. The message is clear. This factory imports an average of 1,500 tons of raw cotton every month from all over the world. All of that cotton needs expensive and time-consuming checking, processing, and decontamination. Because even contaminants as tiny as 30 millimeters can break into thousands of minute pieces, contaminating thousands of kilos of yarn, leading to rejection, compensation claims, and the loss of thousands of dollars. The less contaminated the cotton, the more the demand for that particular cotton, and the more orders and sales for that cotton's growers and ginners. The cotton sector provides income for millions of people in Africa and is an important source of foreign exchange earnings. With funding from the 10th European Development Fund, the International Trade Centre is implementing a project on African cotton promotion and value addition under the EU-African Partnership on Cotton. This initiative aims at improving the competitiveness, value addition and viability of African cotton value chains. Competitiveness starts by understanding market and buyer requirements and addressing constraints in the value chain. Insufficient quality control at farm and gin levels will result in contamination, which not only affects African cotton prices in international markets, but also impacts on the branding of African cotton. The International Trade Centre will continue assisting African cotton ginners to reduce contamination levels and create closer partnerships with spinners through continued support and funding from the European Union.